My name is Oscar Arzu, and I'm here to show you the project that I've been working on for the semester. The inspiration for this project is a Nest thermostat, which is a smart thermostat that you can control from your smartphone while you're away from your home. So I'm going to show you a few things: the hookup, so the hardware, and the pieces of software that runs the system. So let's look at the connections first. Over there I have a wire running from the original thermostat. It uses four of the thermostat wires. The green is for the fan, the yellow is for cooling, red is the 24 volts, and black is heating. Okay. Over now. Okay, so this right here is the actual connections. The thermostat wires, the old thermostat wires, goes to my relay. I'm just using 3 of the relays. The 24 volts is the common. So if a relay is connected, either the green will be connected to common or the other two. So green is for fan. Yellow is for heating or cooling, and the other one is for heating. This is the Raspberry Pi. This is where we're going to be running all the software. Right here, this is the thermostat. I decided to use, or the temp sensors. I decided to use 2 temp sensors because of accuracy. One by itself would give me bad readings every once in a while, so I used 2 and just take the average of the 2 at each set, or each reading. Okay. All right. So let me start. The way I did my system was I have a server running on the Raspberry Pi that's going to be sending the commands to the AC unit. And so when a client connects to the server, it can then issue commands which will be sent out to the AC via the server. Let me show you the interface that I have on the Raspberry Pi. Alright, so first I'm going to run the server. Start the server. Okay, so the first thing you can see is that the server is listening. That's one thread, and then there's 2 threads running in besides the main thread, which is the reading of the 2 temperature sensors. So those will keep on going the whole time. The temperature sensor threads are always updating the variables that the main thread is going to be using to calculate the current temperature. So now I can run my client software. Okay, so the client software will connect to the server, and it's got a system mode for the user to see what mode you're in, and some buttons. You got a cooling button, heating button, circulating button, idle button, and also a auto and a manual button. The states, those are the states that we can put the AC in. So if we're in auto, that means where we can set any of the modes manually. So I will set it to circulate. If you didn't hear, the relays switched on to circulate, and now the AC unit is on. You can see. And I'll turn it off. Hold on, keep it up there. Wow, there we go. So that's in manual mode. We can also set the system to auto mode. If I put it in auto mode, it will use the desired temperature to set the AC unit. So right now I have it set to 75. So if that desired temperature is higher than the current temperature, that means that it should go to the system should go to or automatically go to heating to get us up to 75, which it is in heating. So okay, that's the interface that's on the Raspberry Pi. Let me show you the interface that I have for my phone as well. Let's go over temperature controller. Okay, so now this is the interface that you can use to control the AC unit as well. You can see if I click on air, it changes on my phone, also changes on the display, because they're all updating at the same time. Let's go cooling. You see cooling, it went to cooling. Now the phone doesn't have all the features as I didn't have enough time to implement all the features. So on the phone you could only do the manual inputs. So you can only do heating, cooling, air, and idle.